In this screencast, we'll talk about the lengths of natural numbers. So if we want to code our programs by numbers, then the natural question is, well, how long those numbers are, how long the programs are. So let's consider number 18. The Gödel representation of that number is 1, 2. That's the values of the two prime powers that constitute that number. So it's the power of the first prime is 1, which is 2 to the 1, and the power of the second prime, which is 3, is 2. So 2 to the first times 3 to the second is 18. And so if 18 is considered to be the Gödel number, then its length is 2. So let's let x be a natural number. So what is the length of x? We can define the length of x through our bounded minimalization function that we proved to be primitive recursive in one of the previous screencasts on this channel. You can search it and find out, if you're not familiar with that proof, that bounded minimalization of a primitive recursive function or predicate is primitive recursive. So that the ith element of x, that's the accessor axis function that we covered in the previous screencast on Gödel numbers in part 3, is not 0. So the ith component of x, or and for any index j, such that j is less than or equal to x, either j is less than or equal to I, or if it is greater than I, then the jth component of x is equal to 0. So in other words, what's the common sense interpretation of this definition is that I is the index of the last non-zero prime power in the factorization of x. So, for example, let's if we have some Gödel number, so this is pi is the power of the first prime, and p2 is the power of the second prime, and pi will be the last non-zero power. Now, intermediate powers may be 0, but I will be the last non-zero prime power. So, for example, the length of 0 is going to be equal to the length of 1, and that's going to be equal to 0, right? So here's an example. Let's go through a simple example. So what's the length of 20? So the length of 20, what's the Gödel representation of 20 is, let's see, it's 2 to the second times 3 to the 0 times 5 to the 1, right? So 5 to the first, so it's 2, 0, 1, right? So that's the Gödel representation. So the first component of 20 is 2, and the x is in this case is 20. So the second component of 20 is 0, and then the third component of 20 is 5 1. I'm sorry, it's 5 to the first. So and then for any other I which is greater than 3, so 3 is the last non-zero prime power, right? It's going to be equal to I is less than or equal to 20, right, by definition. So it's all going to be equal to 0. So if if we take x to be strictly greater than 1, so it's, in other words, well, we know that the length of 0 and 1 is equal to 0, then we can observe that if we take the Gödel number a1 through an and access the ith component, then it's going to be a sub I if I is within 1 and n. right? And this is basically by definition of the accessor function for the Gödel numbers, right? And 0 otherwise. So if we take x, right, and apply our accessor functions, right, and extract all of the components of x, x1 through xn, then we'll get back our original x if n is if the length of x is less than or equal to n. So this is obviously true in case if x is 0, 1, if x is greater than 1, and the length of x is n, right? Well, n has to be a positive number in this case. If x is strictly greater than 1, then Pn is the last prime that divides x, and no prime larger than P sub n will divide x. So for any indices greater than n, those that they will be the prime powers of those indices will be 0. So if the length of x is less than or equal to n, then and x is strictly greater than 1. Then if we take the components of x with our axis function and reassemble them into the Gödel number, then we get back the original x. So right, so just another a concrete example. So if x is to continue with our previous example, if x is equal to 20, and 20 is so 2 to the second, 3 to the 0, and 5 to the first. So right, 2 to the second times 3 to the 0 times 5 to the first. So the first component of 20 is 2, the second is 0, and the third is 1. So if we access those components and put them back into the Gödel number, we're going to get back the original natural number x. And 3 in this case is the length of 20.